we're now going to shift our attention and look at sampling. And so when we talk about sampling, we're basically talking about how you select the group of people that you're going to include in your study, again, assuming that you're doing human subjects research. So sampling is basically the process of, again, picking, are you doing individuals? Maybe you're measuring families, maybe you're looking at agency or organizations. And there's two different ways to approach it, and we're going to look at both of them. One is called probability sampling, and the other is called non-probability sampling. So just to make sure you understand the basic concepts, the sample is that subset of a population that you're going to observe. In quantitative statistics, you want to you usually are looking at that sample and you want to assume things about that sample. So if you're looking at substance abuse, you obviously can't capture information from everybody that has a substance abuse issue, but you want to make sure that if you include 50 people with substance abuse issues, what you find out about them can probably apply to everybody else with a substance abuse issue. And there's a lot that goes into how you pick the people to include in your study, because how you pick them and who they are is going to have a lot to do with whether your results speak for something that I can do in one state with substance abuse, or whether they're limited to only something that works with just that one group of people. Again, you want your research, you want to get the biggest bang for your buck in research, and so there's usually a lot of focus on making sure that what you find holds true for everybody else. So let's look at then what it means to generalize. First, let's say you have everybody. This is everybody with a substance abuse issue in the United States. So then you want to draw a sample. You want to pick a group of people from that population that basically represents them, that kind of represents the diversity in that population, so that anything you find out for them can be applied back to the main population, right? So you're drawing your sample and then you're generalizing that this applies back to that group. So what does that mean? Remember we talked earlier that there's validity that applies to your measurement. There's validity that applies to your results. There's also validity that applies to your sample. This is called external validity. So this has to do, again, with how well can you generalize that everything you found out for your sample represents the population from which it was sampled. And you use that, again, to be able to find out how important your results are for the rest of the population. So you've got your theoretical population. In theory, right? This is, you want it to apply to all these folks. Then you've got the people that you're going to include. So maybe I can't practically include everybody in there, so I'm then going to have to reduce it down to a sample. Well, to come down to that sample, then I have to pick a sampling frame. What's that list of people? How do I find out? So there's companies that make a living off producing these lists. So maybe there's a random mailing list that I get that is the sampling frame for my study population, right? So from that sampling frame, I'm going to pull my sample. And so there's probably going to be people that respond to an invitation to participate in a study. So you see, you go from the population, then you define who that study population is, then you come up with a list of who could be in your sample, and then from there, you actually get your sample. So not everybody in your sampling frame will end up in your sample. Okay, keep that in mind. Not everybody in your sample frame ends up in your sample. Now we do have errors, and errors are something we really have to manage and be aware of in research. So what happens if your sample doesn't match that target population? Or what happens if, for example, there's more men in your sample than there is in your target population? Usually there's an assumption that the bigger the sample, the safer you are going to be, but that's not necessarily the case, and we're gonna that's something to be very careful of. If you pick 500 people, but those 500 people have more men than are represented in your population, that doesn't really matter that there's more people, because that error stays no matter how many people you get. You might even be able to get away with getting 50 people, but if they're picked in the right way, that group is going to be more effective in giving you the results you want than that 500 group of people that wasn't picked in the right way. So it's important to be realistic. Is it possible to actually get an exact match between your sample and your population? Long question. Short answer, no. Why? Because we're unique. We're different. There's no possible way that you can get one small group of people that will exactly represent the entire population, but you can get close, and statistics can get you even closer. So here's some of the problems that we see. We looked earlier at measurement error and how you've got systematic error that is produced from bias. Similarly, in sampling, you have bias, which means that maybe the way you picked people is going to keep you from actually getting a group that represents. Sometimes researchers want their sample to represent the population, but maybe that sample isn't going to look like them. But you have to stick to the way your sample is drawn, depending on the technique that you use. Sometimes there might be certain groups that are overrepresented. So maybe you have, again, too many men or not enough women, which maybe that's a result of the mailing list you got. Right now, for example, any mailing list that's based off of home phone numbers does a pretty terrible job of capturing people, especially a lot of younger adults who simply don't have house phones. And so how can you get, if you have a sampling frame that relies just on a list of telephone companies and home phones, you're going to have some sampling errors because you're going to miss a lot of conclusions, and then any conclusions you get about people are probably not going to really be able to apply to, again, those younger folks that don't have home phones.